Hello everyone, my name is Hossein Salafar and I'm a professor of electrical engineering, and I have been with UND for about 27 years teaching and doing research in electric power systems and renewable energy systems and anything related to it. And I want to show you a description of what we do in the lab and the equipment that we have. And to do that, welcome, and let's go in and show you what we have. Okay, well, as you can see, before we start talking about anything else, let me talk about some safety measures and issues that we take very seriously for the lab as we deal with electricity and high voltage, high current. We have a fire extinguisher first, and anyone that comes to the lab is required to use a safety glass or safety glasses, and students who use them are asked to sanitize them when they are done. And also another thing is that students are asked not to work alone in the lab, and anytime they want to use the lab, they should coordinate with some of their colleagues or myself so that they come in and we make sure that nothing goes wrong when they do the experiments. All right, and let me just walk this way and show you some of the equipment that we have. And as I describe some of these equipment, I show you or tell you about some of the projects that we have done and we are currently doing in the lab. As you can see, we have a couple of graduate students. These are PhD students working, and I'll ask them to kind of introduce themselves a little bit later. But let's go this way and show you some of the equipment that we have. What we have here is the equipment that we have built in-house to put a small microgrid together. And this microgrid will allow us to kind of see the impact of renewable energy sources like solar photovoltaics, as well as wind energy on the grid, the performance of the grid. And we look at the voltage and frequency stability of the grid. And to mimic the solar panels and wind turbines, we use amplifiers, programmable power supplies, and all of that. And we have all the equipment we need. Most of it is built in-house, and the other equipment like converters and inverters, we have bought them with grants from either Department of Energy or National Science Foundation, or from the school itself, the help and support that we have received. And this lab is being used by both graduate students for their research projects and for undergraduates for different projects that they are assigned to. For some of the classes that we teach, like electric drives, EE401, we have 4 electric drives stations. These were funded by National Science Foundation some years ago, and this will allow students to kind of hands-on experiment with some of the things that we discuss in class. Now, of course, we also have distance students, and distance students, unfortunately, they don't have access to the hardware, but what we do, we work with on-campus, I pair them with on-campus students, and we try to mimic or emulate some of these experiments through specialized simulation software that students are provided with the help of the company, the vendor that sells the software. They are very generous. They provide us with free software for students, and that helps a lot to teach these concepts of electric drives to students. And We have had undergraduates involved in graduate level projects, funded projects. We pair them with graduate students, like a couple of them right here. And we have another graduate student who had a doctor appointment. He couldn't make it today, but hopefully he may show up any minute. And so on. And I don't know what else I can tell about this part of the lab. And we can talk about some of the projects that we have done using the equipment in this lab. As you can see, some of them, these are the posters that are based on the results of the experiments. Some of them are funded by external agencies and some of them internally, and some of them are just course projects. And there are several of them, like the first one talks about micro power receiving demonstration for spacecraft. We have synchronous phasor measurement unit, or PMUs as they call them, for modern smart grid power systems. And we also have done studies of electric power system stability when we have integrated renewable energy sources like the wind farms and as well as the solar photovoltaics. So these are just some examples, and there are many more that we do here in this lab. Do we want to have the PhD students to kind of introduce themselves and tell us just very briefly what you do and what projects you are working on? We have Shravan. He has been with us and he's almost ready to graduate in summer.
Yes, sir.
And then we have Sina also, who has been with us for what, a couple of years?
For 2 years.
2 years, okay, right on.
Yeah, hi, I'm Sina Ibn Ahmed. I'm a third year PhD student in School of Electrical Engineering and Computer Science. And currently I've been working on grid integration of electric vehicle and hosting capacity analysis of distributed energy resources.
And we work, and he works actually with the Energy and Environmental Research Center that is here on campus. This EERC used to be a DOE, Department of Energy lab, but it went commercial a few years ago, and we have been working with them on quite a bit on different projects. And Shravan?
Hi, my name is Shravan. I'm a fourth year PhD student and I've been working with Dr. Salafer for 4 years. My research topic is developing energy management systems for community microgrids using some advanced technologies like multi-agent systems, and we do a lot of reliability engineering where we use advanced techniques like fault tree analysis, failure mode and effects analysis, and these days they're like cyber components, right? So we do like risk analysis for these cyber components using some advanced risk analysis techniques, and that's briefly my research. Thank you.
Okay, very good. So, and let me show you a little bit on the other side what we have for the lab. Here we have again equipment that allows us to perform different types of experiments like motor controls at higher level, and we use these to represent load on the microgrid. And we have programmable power supplies. We have different equipment like ultracapacitors, and what I'm interested in now is the smart inverters. So I want to introduce both undergraduates and graduate students to smart inverters, which is a key critical component that will help utilities to integrate solar photovoltaics into their mix, and also for wind farms, smart inverters. I'm not going to go into the theory and concepts here, but basically that's what we have. We have several of these motor control station, but because we don't have enough room in the lab, so we have kept some of them in another area, but that's one of them. And that's basically what we do in this lab. And I'm very happy to have presented this lab, and if there are any questions, please feel free. I'm available. Either call me or send me emails, and I will be very happy to answer and respond to those questions. And I want to thank you, Keith, for helping us making this video of the lab, and I want to thank everyone that watches this video, and it's been a pleasure. Thank you.